Hi, everyone, and welcome to Edging Ahead Data-Driven Decisions for Edge AI with RabbitMQ and OpenVino. I know that's a mouthful. But I'm Jamie, staff engineer, edge computing at VMware. With me, I have Roger, who leads product and engineering at RabbitMQ, and Madeline, who's senior director of network and edge at Intel. So it's 2023, and by now we all have a good idea of what edge is. Gartner predicts that the edge market is going to go up to 206 billion. I think that's a typo we have on the slide there. But it's going to be 206 billion by the end of this year. This includes all software spending. So this is all new apps that people are developing at the edge, and including the hardware as well. Now, this is across a range of different industries, so smart hospitals, homes, retailing, manufacturing, you have it. Now, with these increased applications, there's a lot of data being generated at the edge. Gartner predicts that 50% of this data is going to be processed at the edge itself. In a bit, we'll cover reasons on why this is. Gartner also predicts that 75% of enterprises plan to increase their edge investments by about 37%. And finally, up from 208 billion by the end of this year, Gartner predicts that we're going to go to 317 billion by the end of 2026. So as you can see, there's a lot of movement to deploying at the edge. What are the different categories that we're seeing the different applications are? The first one is emerging applications. Now, a good example of this, Madeline actually gave this talk like a year ago, and one of the example that she mentioned was, let's say you have a worker in a store, and they unfortunately have a mishap. There's a lot of CCTVs already at the store. So what if you could process this data at the edge and get the person emergency services quickly? Right, so this is a good example of applications that have been deploying at the edge. The second group of services are AI/ML workloads. Madeline is going to be covering in detail how OpenVino can help with this story. But Gartner predicts that from 5% in 2022, this is going to go up to 50%, and we actually believe that number might be even higher. The third category of workloads we have is virtualizations of operational workloads. A good example is the PLCs. These used to be single-purpose, single-use hardware that you had to deploy at the store. Now, with the support of real-time networks, we are able to virtualize this, and customers can get the power of virtualization for PLCs as well. Another example is point of sales. We're able to virtualize the point of sale system, so you don't need purpose-built hardware for this as well. So let's briefly cover the edge compute stack. Now, this isn't a new offering. This has been in the works for 2 years, and we've been constantly iterating based on feedback we've been receiving from customers. But a few key capabilities I wanted to quickly mention. The first is we have a variety of different flavors for edge, starting from the smaller versions of edge to sizes representing mini data centers that actually run at the edge. We've optimized to run low latency applications, which is why you can run PLCs, etc., virtualized. We allow for GPU pass-through and support for vGPU so that you can run your AI/ML workloads. And of course, you can run your VM and your container workloads side by side. Now, Gartner predicts that 55% of all data analysis by deep neural networks will actually occur on the edge side by 2025. And this is up from less than 10% in 2021. Let's talk about the challenges and why all this processing is actually moving to the edge. The first one is limited bandwidth. At the edge, you don't necessarily have reliable networks. So trying to push all of this data to the cloud actually is very expensive and time consuming as well. So that's why customers are looking to process the data at the edge. The edge actually has multiple systems deployed by different vendors. And now all of these data is actually stored in silos. So for customers to be able to make use of all of this data and combine them, there's no common API and there's no common event standard. So customers tend to struggle trying to combine this data and give useful outcomes for their customers. So what is the solution that we have? The solution is three-pronged. We're using edge compute stack to deploy your workloads. Then we combine it with RabbitMQ, which can be this common data substrate for services to exchange data. And then you have OpenVino, which allows you to abstract out your hardware and allow you to run your AI/ML workloads on any hardware, well, Intel-based hardware. So I'll quickly go over the edge compute stack and then hand over to Madeline to talk a little bit more about OpenVino. So the edge compute stack, as I said, is not new. What's new is the edge cloud orchestrator layer. This is going to be a SaaS solution that's deployed, which allows you to manage all your thousands of edge sites. It's going to be pull-based system, and it's going to be GitOps-based, so desired state-based system. And it's also going to have zero-touch provisioning. So imagine you're able to ship out a device to the store, a non-IT person can plug it in, maybe configure a few details, and then it downloads all your workloads and gets it up and running. A few more aspects to cover. So this will have the edge optimized runtime to be able to run both real-time and non-real-time workloads. As I mentioned, it's going to be pull-based desired state fleet management. Security is going to have inbuilt security because, as we know, at the edge, somebody could just take a physical device and walk away with it. So you have to have inbuilt security in it. We're working with vendors to improve our AI story. I keep saying this, but Madeline is going to talk about OpenVino just in a bit. We're going to have data platform as well to handle services. And Roger is actually going to be covering how RabbitMQ, for example, can be that common substrate for services to communicate. And last but not the least, we have our services platform, which provide edge-related services to improve your edge offering. And now.
All right. Ooh, sorry. All right, thank you, everyone. So up until about 5 weeks ago, I was actually the product manager for the VMware Edge Compute Stack. And so now, as of 5 weeks, I work at Intel. I joined the Network and Edge group, and one of the products that we have is OpenVino. Luckily, we've been working with VMware, and Intel have been working with OpenVino for the Edge for at least over a year. All of the demos on the show floor that are doing computer vision last year and this year are running on OpenVino. And so something interesting that I didn't know, OpenVino actually stands for Open Visual Inference and Neural Network Optimization Platform. And so this OpenVino is, you can think of it as, it's a developer toolkit. You can think of it as a set of APIs that you can run. I'll show you what it runs on. And you'll set it up on the VMware stack, for example, and then you can use it to actually do the inferencing of your models. It also does model optimization, but I'll go through that. But so we see with OpenVino, it gives you a nice way where if you, it lets you, you don't have to think too much about the hardware. It'll run on any Intel platform, so you can use the chip, you can use the GPU if it's there, and you don't have to optimize your model for each different one. Yeah, so now we talk about that there. Okay, so, but before I kind of jump the gun on what the value proposition is, but let's talk a little bit about the challenge. So I think the hardest part with inferencing at the edge, so you spend all your time, in the data center or training a model or in the cloud, building an MML, actually give me a second, guys, sorry. Whew, 5 weeks, this is just 5 weeks of me learning Intel. Obviously, I've learned a lot. All right, let's try that again. So as you spend your time, everything you hear about in terms of machine learning is all about model training. And model training, of course, takes years, a lot of time, and those models are huge, right? Take a lot of processing power, and that's why the GPUs are best used for that. But to the edge, you obviously have a very small platform of various sizes. And how do you take then that model that's been built and run the inference? So the common problem now, if you don't have something like OpenVino, is that you need to take your model with all the different frameworks that are out there and optimize it for each specific chip and hardware. And that's where having something like OpenVino gives you that kind of abstraction layer. So the challenges here is, so if you don't know exactly what hardware your edge has, how do you get the best performance out of that hardware? How do you then, like I said, how do you maintain all these different model codes across all the different architectures? And then also, if you have different locations, you might be running different use cases. And also, as you learn the inferencing at a particular use case, so if we were talking about someone's, running the computer vision to just check if someone falls in the store or checking for store inventory, your model that runs at the inference at the store will then have little pieces of, hey, I didn't understand, I wasn't sure that this was a spill or this was ketchup missing from the aisle. So how do you have a common data plane that then can send those output of your inference back to where you're actually training the main model? And that's somewhere where RabbitMQ can come in to be kind of that transportation layer. So although I've given this talk last year, I'm actually really excited that at least now I can talk a little bit about OpenVino. Again, only 5 weeks of product knowledge of OpenVino. But so how does having something like this really kind of help? Okay, and so I kind of covered this. So actually having the model trained is only half of the problem. It's not what is going to have the most revision. So like I said, at the edge, think about it. Every day you're running all that data that's being fed in. How do we handle it? And then how do we keep all those models deployed? And first, the difficulty in deploying the problem that we have with Edge Compute Stack that we'll solve with its orchestration is how do we get these models, out to the edges, get the data out to the edges. But then here with OpenVino, how do we help you, like I said, with the abstraction? So that's kind of what these slides are going through. So like I was saying earlier, do you optimize for CPUs? Do you optimize for GPUs? And with here, you don't have to worry about them. We can also Intel has, of course, FPGAs as well that run at the edge. So it all gets abstracted together. So I want to get to one slide here. Sorry, guys. So I already talked a little bit about the challenge. And now I'll talk a little about the developer journey. So OpenVino, it both has an open source edition and an Intel supported edition. And it really, with its APIs, you then take the model that you might have taken from your data center or your cloud. We also have something called OpenVino Model Zoo. Intel has tons of sample applications because another statistics from one of the analyst conversations I had is that actually an analyst was reading out to us about some common observations they learned about enterprises. So what they said is that most enterprises don't start, they don't have the 2 years to go build a brand new model, that they will take a version of a model that is out there or some of the samples that we've developed. And then from there, you will then train it with your own customized data. And then that model you probably want to not run in the cloud, like the problem with people saying, oh, if I run ChatGPT on my data, then all of a sudden it's going to learn. Well, you take your own private copy and you'll train it and update it from there. But from that is then how do you have all these versions to the edge, like I was saying. So OpenVino lets you have a toolkit to do model development. It lets you optimize the model for the various types of Intel platform, and then it'll then help you package it to deploy it. Perfect. And this picture kind of highlights all the different optimized platforms that it works for, but what's interesting there is that we've also announced ARM support this year, so it's more than just the Intel platform. And it'll run on all the different operating systems. So we do Windows, Linux, Mac OS. And then, of course, you can bring your own tools for how you want to build your model. PyTorch, TensorFlow, and Caffe, I think are the most popular ones, but we support a variety of them. And so that's what makes this value proposition really exciting. The fact that we've expanded to ARM, and the fact that if you use the OpenVino toolkit and runtime, that you can build your model once, hopefully, and then deploy it out with the help of different platforms like VMware Edge Compute Stack, and putting it together with the data platform that Roger will talk about now really kind of brings you that full solution together. All right. Thank you for bearing with me on my first talk for Intel. Thank you.
Thank you, Marilyn. So, as Marilyn mentioned and Jamie mentioned, one of the problems of processing data on the edge is that communications sometimes, depending on the use case, are not reliable, right? Sometimes get interrupted, etc. Sometimes the bandwidth is not the right that we are expecting. The amount of data that is generated will probably block the connections back to the central hubs. So where we can help on that? Data processing in the edge must happen, but it has to be contained and it has to be well anticipated. So essentially, it will help on providing real-time decision-making, right? It also helps to increase application reliability because the application can start understanding what are the challenges that is facing on the edge itself, right? But one important aspect where RabbitMQ is especially good at is it has to reduce the bandwidth and the infrastructure cost, right? When you see the VMware Edge offering, As you have seen probably, this infrastructure allows the user of that server model to deploy applications on whatever the format they have already on the cloud, or on containers, or VMs, or whatever is the format, because a lot of these applications, some of them are legacy, some of them are not, right? RabbitMQ can help on that because RabbitMQ is deployable in both formats and fully compatible in whatever the platform that you have on the edge, including ARM. Another one that is interesting, another advantage that has processing data on the edge is enhance the customer experience. We can train our applications to change behavior depending on what is the model that we observe on the edge. And then obviously the communications have to be secure, right? All this data has to be transferred on a secure manner, right, to avoid problems on privacy, especially on these distributed edge locations that sometimes are a little bit isolated. So I don't know what I did. Sorry for that. So when running critical new edge applications, we really have a common pattern, right? We are capturing data, right? There are many IoT devices, many devices that are on different areas on the edge space. We have to capture this data on a secure manner, right? But then we need a unified transfer to simplify operations on the edge, right? But at the same time that we are collecting and capturing data, we have to send it over to the final destination of this data. And we serve and we provide the ability to process this data where it belongs. We can store it locally, or we can send this data to whatever robot is on the edge, or we can simply send an abstraction of this data up to the analytics platform for a later processing. All this supported by RabbitMQ. RabbitMQ is extremely flexible. It helps us capture data. It has a wide variety of protocols and controls. It supports up to millions of concurrent client connections, which is a common use case on the edge. And then it helps us to escalate, to fit the different store models where we want the data to be persistent, either on the edge or up to the cloud. So why RabbitMQ is efficient on the edge, right? In the capture, we support a huge variety of protocols and languages. As you know, especially on the capture process, every vendor creates devices, and the API and the client tools to connect to these devices have different languages, right? So Rabbit has a wide variety of languages that can interact with whatever device that you may have, right? Format types, that's another one that's very interesting. Rabbit essentially manages all this as data that flows on the bus. It provides two constructs: message broker with guaranteed delivery of the message, or streaming, because not all the data that is captured requires the exact same pattern, right? That's a very interesting one. And then obviously on the quality of service, we provide ability to understand what is the capture rate and what are the variations that we need, and we can provide policies to adapt Rabbit for that, right? It's highly available. It can deploy with multiple instances at the same time, so we can adapt to the edge requirements that Rabbit has, and we support a huge number of concurrent connections, right? Another important data for IoT use cases, we are releasing MQTT 5 support very soon, okay? Again, the wrong button, sorry. Store. That's another one that's very interesting, right? On the messaging cases that we have on the edge, sometimes the data disconnect, we have to buffer, we have to warranty that whatever the data that we have to send over, the client will have warranty that's going to be sent, because it could be important data for the hub, right? We store on a very efficient manner. We have our own storage model compatible with most of the storage solutions on the market. It's scalable. We can scale horizontally and vertically, right? And we have an availability model that we can also implement warm standby solutions in case of critical installations, right? Obviously retention policies, and then we also have deduplication to avoid consumption of messages on multiple client connections that are redundant, okay? In terms of serving, we support the lousy coupling model, right? We support message queues, typical even broken message brokering model. One subscriber requests a message, it consumes the message, and once the message is consumed, disappears from the queue, right? Or we support the model of streams. We generate a lot of messages that are belonging to a similar structure, and then the client can obtain a copy of this message when needed. And the good thing of these two models is that we can have multiple applications consuming the same structures, okay? The next one is very interesting because on the edge, we have poor connectivity conditions very often, right? Rabbit has a model and a series of policies that can help you to adapt the server model to whatever the poor network conditions we have. And another one that's very interesting is the flexible routing models and filtering that we establish both on streaming and queues, okay? It's secure. We support encrypted communications as well, but Rabbit, since maybe you know, is one of my engineers on the latest releases, we added FIPS compliant on Rabbit. I think it was on the last version that we released, right? And obviously it supports different policies for access control, and we can essentially secure the data and make sure that the data is delivered to the application that has rights to get this data. So, but the most important thing is on a model that we need on the edge, a message broker or a streaming model. In some solutions in the market, you have to install two products, right? In RabbitMQ, we really have one standardized model for capturing, and we can follow these two different patterns with a common API and a common set of constructs. So we simplify the administration for both of the two models. So one example of RabbitMQ at the edge, right? We can use Rabbit essentially to connect or to establish the trustable relationship in between a customer app running on the cloud or on the data center, and then the corresponding Rabbit client on the factory, on the edge, where interacts with multiple different types of applications that are running locally, right? On this case, when the customer app that sometime that's most likely is going to be on internet starts an order, this order flies to the inventory order app that is on the edge, and then this via client is able to interact or on the same edge or back to the cloud with the purchasing model that will generate the invoice and all the structure for the sales process. But at the same time, the same message can be used to trigger the production model, right? And that can interact with the QA team, the dispatch team, but also on the IoT devices that will produce the goods that this company on the edge will produce. In some cases, because the edge is going to be a complex process, we can accumulate all the different portions, part of this factory process, and use streams to essentially communicate back to the edge the status of the different process. So what we gain? We gain flexibility, messaging and streaming on a simple solution, scalable. If we need add additional capacity, RabbitMQ scales horizontally as well. Flexible because it's deployable on VMs or on containers. And if on the edge you want to use what it was showed yesterday, which is the edge services running Kubernetes, we have an operator that allows to manage Kubernetes on the edge via an operator. It's interoperable because it's able to connect to different endpoints and spread or connect on a different systems that will store the data depending on the requirements of the business. So we support several languages, as mentioned, several protocols. Remember that on the edge, there are some areas, especially in industry, right, that there is a wide variety of protocols. You have to have a tool that is flexible and extensible, okay? And again, another aspect that is important that I haven't mentioned is that is a decentralized architecture that allows to have warranty of delivery of the data that has to be sent. Okay, as Marilyn was mentioned, we can embed OpenVino on the picture and then have some edge AI capabilities where we index some of the data that is generated, and Rabbit can essentially go and distribute all this data on the different parts of the business that we have on the edge, and finally provide a response back without flooding the network, okay? So that's gonna be it for us. Then I will recommend if you can take the survey, and if you have any questions regarding the edge offering, OpenVino or RabbitMQ, we are here to help. Any questions so far? How many of you have edge deployments today? You?
Yes.
I see.
Distant past.
Excuse me?
Distant past.
Oh, I see. So, who in the room knows RabbitMQ and OpenVino? RabbitMQ? OpenVino?
All I'll say is the value prop I keep, like, from putting my old VMware hat back on. I really do believe that you need to have, for the edge, no matter the workload, whether it's an AI workflow or you're doing, PLCs and you're getting all the different sources from the different devices, like, to really be able to do that closed loop feedback, all those new use cases are happening at the edge. You need to have some kind of common data platform, and that's really
Yes, please.
Yeah, we have some similar, like Enterprise Service Bus, SOE, the microservices or the APIs translating data, sub type functions. You can either build your own or pretty much buy a COD solution. We're starting to find out that maintaining a COD solution ends up costing you a lot more money for functionalities, and it's kind of better to go off to a COD solution that you have more support and engineering fees to help support it and build it out. I mean, somewhat similar to what you have, or MuleSoft, or something similar to that. We start finding out that if you start building things in-house, which you can, you better have the level of expertise and patience, but it does seems like in the long run cost you more.
Yeah, you now mentioned a solution. Another aspect that is relevant on RabbitMQ is that it's lightweight enough to run on edge conditions. That is another relevant aspect, very important.
Very critical, because
yeah.
also if you federate them, not all services need to go in those AORs or those locations. So it depends on what you're doing in those locations.
And sometimes the refreshment of hardware in the edge happens on a different cycle. It's very important to attach a solution that is very lightweight and optimized to what you have.
And it's critical what you mentioned earlier about the different processors and different architectures, they don't always fit. You run into problems. So we start finding out what, like, mostly government, we build Intel chips.
Okay, then thank you all. And if you have any question, please feel free to send. We are going to be sent some email to this address, and we are going to be on the booth showcasing this. There is a booth for OpenVino, and we are also showcasing RabbitMQ here at the expo. Correct. Thank you all.